For the next part, we are going to compare what we're going to draw. We've already drawn polygons. We have already compared polygons, different types of triangles, and now identifying polygons. We're going to watch this video. Okay, boys and girls, for this part, you would need a geometry template, and you can see in our geometry template we have all different types of polygons. When it has 8 sides, we know that we have to call it an octagon. And over here, we have 6 sides, which is a hexagon. Over here we have 5, which is a pentagon. And we have a couple of parallelograms, which are also known as rhombus. We have right here a scaling triangle, an equilateral triangle, an isosceles triangle, okay, a rectangle, trapezoid. So go ahead and draw these, okay, in your notebook and label them, name them. If there's one that you do not know, please leave it blank and we will review it in class tomorrow. Remember not to draw anything that has a circular line or round, because that is not a polygon. For our next question, we are going to find the missing angle. As you can see here, boys and girls, we have a triangle, okay, and we know that a triangle is always equal to the sum of all the angles is equal to 180 degrees. Here we have 88, and here we have 28. So what is the angle that's missing? Well, that would be simple to solve, because we need to have 88 plus 28 plus angle A, which is missing, equals 180 degrees. So what would be angle A? You can isolate this variable and invert these values to this side. So take the 28, subtract it from 180, take the 88 and subtract it from that number as well, and that'll give you your value of A. We're going to continue finding the missing angles. Here's a little bit of a more complex question. I want you, boys and girls, I think we did this one in class, but I want you to do it again just for practice. Now, let's make it bigger. Please draw something similar to this in your notebooks, okay? And find the angles, such as these angles here. Now remember, this is a triangle. So a triangle must equal 100. The sum of all the angles must equal 180 degrees. Okay? So this one right here, this number with this number and this number must equal 180. Here as well, because it is from 0 to 180, this is a flat line, imagine another triangle here. So this angle plus this angle must also equal 180 degrees. And then the sum of all 4 of these angles must equal 360. Or you could also just say there's a triangle down here. Okay, so this 50 plus a number must equal 180. Okay, and the sum of all 4 right here must equal 360 degrees of all these 4 angles right here. And you've already got the 50. And remember that angles that are adjacent to one another, such as these two, equal 180. And angles that are vertical, such as these two, are equal. So this one, you know, is 50 degrees simply because this one is 50 degrees. So vertical are equal, and whatever this needs to be must be equal as well. 50 plus a number equals 180. Okay? So go ahead and solve this. Pause the video now so that you know, pause the video now so that you can try it, and I will put the answers up in about 2 seconds. So here we have it. This is what you should have. As I mentioned, vertical angles are equal, so you know that that's 50 and this is 50. That gives you 2 angles for this triangle here. It gives you 2 angles, so 90 plus 50 is 140. And you know you only need another 40 to have your 180 degrees. Okay? You know that vertical angles are equal, and adjacent angles, angles side to side, must equal also 180 degrees. So 50 plus 130 also equals 180 degrees. And same goes on this side. Okay? And also this vertical angle here is also equal. So vertical angles are equals. Adjacent angles equals 180. Okay, in our last example, we just talked about adjacent and vertical angles. I want you to use this image here to identify a couple of angles. The first one I want you to tell me about is, tell me which angle is vertical to angle EBA. Which one is vertical to this angle? That's going to be the first part of this question. So which angle is vertical? And for the second part, please tell me which angle is adjacent to angle EBA. So next is, which one is adjacent? Go ahead now and pause the video and analyze this. We have angle EBA. Angle EBA. We're asking which one is vertical. Vertical, remember, is directly across. And which one is adjacent to angle EBA. Adjacent, remember, is always next to. So next to, this angle is next to this angle, and this angle is next to this angle. Okay? So your answer should look something like this. Okay? Angle EBA is adjacent to, or sorry, the first one is vertical to angle DBC. DBC. So EBA is vertical to DBC. And for the next part, angle EBA is adjacent to angle EBD. Angle EBA is adjacent means next to, angle EBD. There you have it. And for the last skill, making tessellations. Tessellations can look as the following. It could be something as simple as a tessellated group of triangles, which look to be equilateral. Yes, they're all equilateral triangles. Okay, right there. It could be a combination of rhombuses, parallelograms, or isosceles triangles, as you see there. Or it can be as complicated or a little more challenging as this group of hexagons, okay, squares, and isosceles triangle. Sorry, not isosceles. Well, that is an isosceles, but it's also an equilateral triangle, as you see there. In your notebooks, please make 2 tessellations. One tessellation using only one type of polygon, as we've done here, only one type of polygon. And in your other tessellation, you can use as many polygons as you like they did here or here, but make sure they tessellate. To tessellate means they cannot cross over and cannot overlap, or cannot cross, the lines cannot cross, and they have to be polygons fitting together. Okay, boys and girls, I hope this video helps, and I look forward to seeing all the work you did in your math notebooks. See you in class.